Without any further delay, I will introduce you the first speaker, who is Professor Éva Hartai. Éva is a geologist. She's an honorary professor at the Miskolc University in Hungary. Her research area is ore geology and mineral resources. She has more than 40 years of teaching experience leading courses in physical geology, environmental geology, and mineral deposits, and has taken part in several EU and national research projects. She has more than 80 scientific publications, and she has been editor-in-chief of the European Geologist Journal and coordinator of the EFG panel of experts education. So Éva will talk about potential targets of small-scale robot mining. So Éva, whenever you're ready, the floor is yours.
Thank you very much for this kind introduction, Claudio. Our university of Miskolc, is responsible for the geological and mining background of the ROBOMINERS project. And the title, Claudio didn't mention the complete title, Resilient Bio-Inspired Modular Robotic Miners. Maybe the bio-inspiration is the most innovative part of this project. The project started in 2019 in June, and originally it was planned to be a 4-year-long project, but because of the working difficulties due to the pandemic, we asked for a 6-month extension. We have 14 partners from 11 countries, plus one of the partners, the European Federation of Geologists, brought in its national member associations, which cover 17 countries and contributed to the data collection. The basic objective of the project is to reduce the EU's import dependency of strategic raw materials and help the EU to get these resources, get these materials from domestic resources. How is it possible? By the exploitation of mineral deposits which are not economic by traditional mining because they are too small, too deep, or difficult to access. For this reason, the consortium develops a modular reconfigurable robot miner, which is capable of selective mining underground in a flooded environment. These are the specific objectives: to construct a robot prototype, validate the key functions, design the mining ecosystem, and study and advance future research challenges related to the capabilities of the project. The concept is that the robot in parts, in modules, would be sent down to the deposit through a large diameter borehole. And from this part, the robot would assemble itself. It will be equipped with specific sensors, so it will be able to detect the metal enrichments and follow the ore. And it will produce slurry. This slurry is pumped out and processed on surface. So this is shortly about the project itself. As for the geological background, we started the work with the review of the mineral deposits which can be relevant for the mining. We described and characterized these deposits, and in the frame of the working group session, in which the advisory board members were also involved, we ranked these deposits. The ranking was based on these parameters listed here, and each parameter could have a maximum of 5 points. And it turned out that the sediment-hosted stratiform copper mineralizations, the so-called Kupferschiefer type mineralizations, are the best targets. Why? Because they are extensive two-dimensionally, they are relatively thin, easy to identify and easy to follow. For similar reasons, the vein type mineralizations are also good targets. Here the problem can be that the veins in general are vertical or subvertical, so the robot should be able to move vertically. We also built up a database. The EFG's linked third parties collected data from 17 countries on former abandoned mining sites. They collected historical data, the geotechnical conditions, deposit site, a lot of kinds of data. It may be surprising or impressive that from these 17 countries, which are indicated here, from these 17 countries, 1,548 sites were identified which are potential targets. So these data will be visualized and it will be available, accessible through the project website through an interactive platform from July this year. So if you are interested, you can visit the website. We also set up mining scenarios in which the robot can work. 3 mining scenarios were defined. First, abandoned mines, and also operating mines with known unfeasible sections. Second is the ultra depths. What do we mean by ultra depths? We should think in terms of Europe. So as in Europe, the deepest mine, Pyhäsalmi in Finland, is almost 1,500 meters deep. Below these depths, we consider the ultra depths. And the third scenario is the small deposits, which can be good enrichments, but uneconomic for traditional mining because they are too small. In the following, I would like to provide a short outlook on potential targets in Europe. I arranged these sites in the main metallogenic belts, which overlap with the main tectonic units. These are the East European Craton. We will focus on the Fennoscandian shield part of it. The Caledonian Belt, which includes Western Scandinavia and the British Isles. The Variscides range, Iberian Pyrite Belt from France to Poland, also including South England, and the Alpine range, Alpine Belt, which includes the Alps, Carpathians, Balkans, Dinarids, and Apennines. As for this European Craton, you can see that we have a lot of examples, a lot of mineral deposits we have here, and a lot of examples for abandoned mines and also operating mines with unfeasible sections. I would mention first the Skellefteå and Bergslagen regions, maybe also Pyhäsalmi from Finland, for the base metal mineralizations and also the precious metal mineralization. And as for the precious metal, we have to mention in Lapland Kittilä, which is the largest gold mine in the European Union. And also mention the Norrbotten and the Bergslagen regions for the rare earth element potential in the alkaline magmatites, and also Outokumpu here, which again base metal and nickel chromium precious metal mineralization. Finally, the Kemi deposit is mentioned here because this is the only operating chromium mine in the European Union. I wouldn't consider Albania, no, only the European Union. And this can be also a scenario for the ultra deep, because this is a layered chromite deposit and the layers slightly dipping, and they were identified by geophysical methods at a depth of 2.5 kilometers. Next belt is the Caledonides. Scandinavian part first, you see that there are a lot of base metal and precious metal deposits, but other kind of mineralizations. As for the abandoned mines, I would mention only the Kongsberg silver district. It's a historical mining region because mining activity lasted for more than 300 years here, and still we have 80 identified old mining sites. Here within this zone, we can also find an example for the ultra depths with the alum shale. This alum shale is a bituminous shale which was mined as a uranium ore containing other important strategic elements, and it is close to surface in the northern part of Scandinavia and dipping southward, and in southern Sweden and Denmark it was identified by petroleum exploration drill holes at a depth of 7 kilometers. Finally, the Fen complex in the Oslo Graben, again for the rare earth elements potential, first of all, but with other metals. This area is only explored, mining hasn't started here. Still in the Caledonides, in the British Isles, Ireland has a larger importance with abandoned mines and operating mines. Here you can see the larger deposits, the Tara mine, maybe the largest one near Navan, and these are mostly vein type mineralization with zinc, lead, silver. So both abandoned and operating mines, a lot. From Scotland, I would mention only one site. This is Tindrum. It may be interesting for us because it is the reopening of an old mine at quite a small scale, and gold and silver is mined here. Going to the next belt, Variscides belt. Let's see first the Iberian Peninsula, and I would focus on the Iberian Pyrite Belt here, which stretches more than 200 kilometers and the width is 70 kilometers, mostly volcanic massive sulfide type deposits. It has a long mining history, as mining goes back to 8th century BC or even older. Copper is the dominant metal, but also other metals, including precious metals, were mined. And the area still has a very good potential. Here, a few important mining sites are indicated. Still in the Variscides belt, beside Iberia, there are several examples for abandoned mines and also small deposits. If we start from here, from Cornwall, Cornwall was famous for the tin mines, or tin and copper mines, but also mining, producing other metals. And again, a very long mining history, which goes back to 2000 BC. This is a Craton type mineralization, and we can find a similar type of mineralization here in the Erzgebirge or all mountains, which can be found along the border between the Czech Republic and Germany. Craton type mineralization, as I mentioned, and with tin, silver, lithium, tungsten, uranium. Hundreds of years of mining activity, and lately, not long ago, it was pointed out that at Chinovec, which is the Czech part, the largest lithium reserves of the European Union were found. There are lots of abandoned mines in this belt. I would mention only one, Rammelsberg in Germany, which acts now as a museum mine. And here in this Variscides zone, we can find the best example for the ultra-deep scenario with the Kufer-Schiefer formation, which can be followed from England to Silesia, Poland. Basically, it's a copper ore, but contains a lot of other metals. And while, for example, in Germany, it is near surface, in southern Poland, Silesia, it was identified by drill holes at a depth of 2 kilometers. So an excellent example for the ultra-deep scenario. Finally, we arrived at the Alpine zone, Alpine Belt. From the Alps, I would mention the orogenic gold deposits, which can be considered as examples for abandoned mines. But I should also mention Mittersill as an operating mine because it's a world-class deposit, world-class tungsten deposit, also producing other metals. Here in Slovenia, we find again a world-class mercury deposit at Idrija, which was closed. The mining was seized not long ago. If we go towards the Carpathians, in the Carpathian zone, there are numerous abandoned mines because in this area, the precious metal, the mining of gold and silver was very active in the Middle Ages. So we have a lot of abandoned mines in this area from the Middle Ages. I would mention only one, Rosia Montana, not only because the mining activity goes back to the Roman times here, but also for the long-lasting debate on the potential opening a mine here. So finally, it was in 2015 that the Romanian parliament decided that the mining activity is not allowed in this area. If we go a little bit south, the Balkan Peninsula, you see the large variety of deposit types here, examples for abandoned mines and also operating mines with unfeasible sections. I mention only one, Chelopech in the western part of Bulgaria, because it's a significant copper and gold producer. And from Albania, I would mention the platinum group element bearing poriform chromite. So finally, you could see that the potential is here in Europe. And there are a lot of mineral deposits which could be exploited by the ROBOMINERS technology. Let's hope that it will be realized in the close future. Thank you for your attention.